Hello everyone, in this video I will present my EEE 412 microwave electronics project. In this project I worked on the design of an amplifier with these specifications. For this schematic I determined the values of the resistances by assuming that the current IC, which is suggested to be 50 mA, is equal to 10 times the current passing through the resistance whose ID is R4, and the base voltage of BJT is 0.8 volts. As shown in this figure, I put decoupling capacitors and DC block capacitors for the DC part of the amplifier. For the RF part of the amplifier, I determined the transmission lines and the input-output matching network so as to satisfy the requirements of the S parameters mentioned in the objective section. This is the input matching network including the resistor to satisfy unconditional stability. Also there are some transmission lines converted into microstrips which provides the connections between components. As for the output matching network, the aim of the resistor and microstrips are very similar to the ones in the input matching network. Next I will show the simulation results. The plots of K with respect to the frequency satisfy the corresponding specification mentioned in the objective section. The nominal gain indicated as magnitude of S21 and the gain variation satisfy the corresponding specification mentioned in the objective section. The plot of the magnitude of the S11 and S22 with respect to frequency satisfies the corresponding specification mentioned in the objective section. By using microstrips and the HSMA connectors, I simulated the PCB design of the amplifier. I provided via holes for the ground pads. In the hardware implementation, I connected these via holes through wires. Then I soldered surface mount components. I also examined the unconditional stability by observing the increase in the current while gradually increasing the voltage of the power supply to 12 volts. In this regard, I observed no sudden jumps in the current while increasing the voltage, which means unconditional stability. From now on, I will show the implementation results. The nominal gain and gain variation do not entirely satisfy the corresponding specification mentioned in the objective section. The plot of the magnitude of S11 and S22 with respect to frequency does not entirely satisfy the corresponding specification mentioned in the objective section. I think the reason of such difference between the simulation and implementation results might be that I was not able to solder the surface mount components to their exact positions, since these are small components and can be held only by tweezers. During P1 dB measurement, the power of the applied RF signal ranges from -25 dB to 10 dB. I measured P1 dB at 1.5 GHz and 1.75 GHz. This is the measurement at 1.5 GHz. And this is the measurement at 1.75 GHz. These figures indicate the noise figure measurements at particular frequencies. For P3 measurement, I applied the two mixed signals with different frequencies to the amplifier. So this is the end of my presentation. Thank you for your attention.